Hi, this is Dr. Nick with the ECG Academy, and we're going to continue our discussion of atrial tachycardia in this section. This chapter is on atrial tachycardia with aberrant conduction, or aberrancy. This is the bane of most monitor techs because they're constantly trying to figure out if a wide complex tachycardia is atrial with aberrant conduction or is it ventricular tachycardia. Now, there'll be a whole section in diagnosing wide complex tachycardias in the advanced course, but for the sake of this discussion, we'll talk about what atrial tachycardia with aberrancy looks like and how to try to identify it on a rhythm strip. So, imagine you have some kind of atrial tachycardia that's going round and round at a rapid rate. You know the AV node may or may not conduct them one-to-one, but let's assume the AV node is good at conducting. What happens if this tachycardia reaches the bundle branches and encounters a functional bundle branch block or some other kind of rate-related interventricular conduction delay? Well, you're going to get widening of the QRS complex because this rapid beat will not be able to get down one bundle, but can go down the other bundle and then sort of like dipsy-doodle very slowly through the rest of the myocardium, giving you a wide QRS complex. The things to look for when you're trying to diagnose an atrial tachycardia with aberrant conduction is that, of course, the wide complex tachycardia should start with a P wave, and you should be able to see P waves marching through at a relatively normal or slightly prolonged PR interval. So remember, P waves can be superimposed on a T wave, and they'll look like a very sharp deflection, up or down, depending upon where it's coming from. And then the QRS will be wide because of interventricular conduction disturbances. And if you're lucky, you should be able to map out the P waves as they're marching through this arrhythmia. Well, let's take some real examples here. As I mentioned in the last chapter, don't ever take what you read on a rhythm strip as being the truth. Always figure it out for yourself. This patient supposedly had possible 12 PVCs in a row. I think you would normally call that non-sustained ventricular tachycardia, but we'll go over that in the last section in the basic course on ventricular arrhythmias and how to name them. But if we look at this rhythm strip, we can see that it starts off with something that looks like a sinus beat with a fairly normal PR interval. And then when you look at the forest, you see that there's this run of a rapid arrhythmia in 12 beats. And if you look at the QRS complex, it looks different than the underlying beat. It's deeper, it's a little bit wider, but it's not very wide. And you have to wonder, why is this looking different from the underlying rhythm? Is it because of an interventricular conduction delay or aberrant conduction? Or could this be some kind of ventricular arrhythmia? Well, how does it start? If we examine this T wave, it looks fairly flat, but obviously this T wave has a P wave superimposed on it. And this P wave precedes the first beat of the tachycardia, and the PR interval looks to be even just a little bit longer than the underlying PR interval. So that would make you think that this P wave is an atrial premature complex, or APC, or atrial premature beat, and it resulted in a widening of the QRS complex because it landed right at the point where one of the bundles, or at least part of the conduction system, was refractory. And so you had an APC with aberrant conduction here. Well, what comes after that? You have another QRS complex, which looks exactly the same as this one, and there does appear to be a P wave in front of it. If you look at the PR interval, it's even gotten slightly longer. And if you scan across, I think it's easy to see that there are P's kind of marching through, each one superimposed on the previous T wave. And in fact, what I demonstrated in earlier videos is that the relationship between the QRS complex and the following P wave varies. So you can see this one comes a little bit sooner, and then this one comes a little bit later. So it's not part of the T wave. It's separate from the T wave. It's moving around, and that gives you more evidence that this is indeed a P wave, and each one of these P waves does appear to conduct one-to-one to the ventricles with variable PR interval depending upon how fast the tachycardia is, until this P wave, which is the last P wave of the tachycardia, and it conducts to the ventricles, And then notice that this T wave doesn't have a bump on it. And so there's no P, and of course there's no QRS following it. So this was a run of atrial tachycardia, but the QRS widened out because of the rate, and I think it's fair to call this a rate-related interventricular conduction disturbance or rate-related aberrancy. So it's atrial tachycardia with aberrant conduction. Well, it was mislabeled on the strip, but I'm sure you won't make that mistake the next time you see a strip like this. Okay, let's go on to one more example here. And this actually looks really nasty. Yeah, I mean, a lot of people would look at this and seriously consider whether this could be a run of ventricular tachycardia, which, of course, we'll get to in the next couple of sections. Looking at the forest, you have 3 fairly normal beats and then this run of a wide complex tachycardia, what looks like a normal beat again, and then another different wide complex tachycardia. It's 4 beats of a wide QRS, but it looks different than these beats. But remember what I told you about atrial arrhythmias with aberrant conduction. What you're trying to do is look at how it starts. You need to see how it starts in order to get a clue as to where it came from. So here we see a nice P and a QRS complex, and here's another sinus P and a QRS complex. So everything is fine up until this point, but here's the key, is looking at this T wave compared with this T wave. Is there a difference? Do we see anything that looks like a P wave? And yes, indeed we do. Right there, there's a little notch in the T that did not exist either here or here. Always look at the T wave, that's where the clues are. So if there is a P wave and it's premature, because obviously the next sinus beat would have occurred somewhere here, this is a PAC, and the QRS complex that follows that PAC has a fairly normal PR interval, a little bit longer, in fact, I think, than the intrinsic PR interval. And that's because it's a premature beat that encountered a little bit of delay in the AV node. You have this wide QRS complex that occurred because of a functional bundle branch block. And it kind of, let's assume that this is V1, it kind of sort of has this left bundle branch block looking pattern with a deep QS kind of appearance to it. But then where'd all these come from? Well, let's look in front of each QRS complex and see if we can identify a P wave. So here's this QRS complex. Is there a bump on the preceding T? Yes, indeed there is. It's right there. And let's look at this one. I think this T wave looks very pointy right here. And here again. And here again. And look, there is a P wave that's clearly identifiable in front of every one of these QRS complexes. This one becomes a little bit difficult to see because the P's and the QRSs are slightly moving apart from each other. But if you take your calipers, and I'll pull them up right now, if you take these calipers and put them on the P waves, you'll see that they actually do map out. It's quite regular. And if we put our calipers on a heavy line, we can see the rate here is about 200 beats per minute. And those P waves march out, and they're coming right on time. And I would say that this is a run of atrial tachycardia with aberrant conduction. But you want to see something really cool? Here, you can see that there's a bit of a pause. And following that pause, there's a P that occurs that's on time, if we're considering this to be an atrial tachycardia. And then the next one occurs on time as well. Now, why did this QRS become narrow and normal looking? I'll tell you why. Because this P wave blocked in the AV node. You had a second degree AV block that occurred right there. So this P conducted to the QRS, but this P blocked. Now you have the pause that refreshes, and the bundle branches recover. This P now conducts with a fairly normal PR interval down the bundle branches that are both capable of conducting. But then this P, which is also part of the tachycardia, I showed you it came on time, now, of all things, encounters a different bundle branch block. Look at how this QRS complex is going in the opposite direction. So this is a left bundle pattern, and this is a right bundle pattern. And the PR looks a little bit long, but if you take those calipers and move them, you'll see that here's the next P, and here's the next P, and here's the next one. And so these P's are marching on through. But what you had was one bundle branch block, and then you had one P wave that failed to get down the AV node. That pause that resulted allowed for normalization of the QRS complex because now both bundles are conducting. But then the next P wave from this tachycardia wound up finding the other bundle blocked. And then you have a run of the opposite bundle branch block. Now, this is not the same as bilateral bundle branch block or anything crazy like that. This is simply one aberrant conduction, and then it happens to be followed by aberrant conduction in the other direction. This doesn't necessarily mean that the bundle branches are diseased, because it's coming at a rapid rate. This is 200 beats per minute. And so it's a functional bundle branch block. It doesn't mean necessarily that the bundles are sick, but under these circumstances, they did not function properly. But this is a great strip here. I think if you showed this strip to a lot of people, they would not get that as being an atrial tachycardia with aberrant conduction. So I hope this lesson straightens things out for you and gives you some ammunition in fighting the idea that every wide complex tachycardia is ventricular in origin. The last video in this series is going to talk about unusual types of atrial tachycardias, and I hope you enjoy that one as much as this one. So this is Dr. Nick for the ECG Academy. Thanks for watching.